inverse trig derivatives. Okay. The trig derivatives are in front of your face because I printed them off for you, so you don't have to write them out.
I wrote them down.
Trig derivatives, I'm going to tell you right now, the hardest part of the inverse trig derivatives is memorizing the inverse trig derivatives, not actually doing the work. But if you look, they're very similar. So sine and cos are the same, except cos is negative. And then tan and cotan are the exact same, except cotan is negative. And secant and cosecant are the exact same, except cosecant is negative. So there really are only three to memorize, right? And then the c's are negative, just like the derivatives if c's are negative. Okay. So, determine the derivative of y equals sine negative 1, 3x squared plus 6x plus 7. I'm not lying when I say the hardest part of this is knowing what the derivative actually is. That's it. Inverse trig derivatives, just like trig derivatives, have their specific derivative, but if something is beside the sine or the cos or the tan, you have to do chain rule, right? In this case, if something is beside the sine negative 1, you have to do chain rule. Okay? So when we did the derivative of sine, it was cos x. And we would just go cos of whatever was in the brackets and then times the derivative of what was in the brackets. We agree? So here, we're going to do the derivative of sine neg 1 first, which is, we're right here, d over dx of sine neg 1x equals 1 over the square root of 1 minus x squared. So this case is if there was just an x, the x would go here. We agree? So if there's something more complex than just an x, that has to go there. So we're going to get y prime equals 1 over 1, the square root of 1, minus x just happens to be 3x squared plus 6x plus 7. 3x squared plus 6x plus 7 squared. Now what have I not done? The derivative of the x. So I just multiply it behind. So I get 6x plus 6. And technically that's just going to join the 1 because this is 6x plus 6 over 1, correct? So it ends up just going in the numerator. Thanks. So you're going to get 6, if you want to, x plus 1, like that, square root. So the derivative is not the hard part, like actually doing the derivative. Having them memorized, the hard part. That's it. Okay. That's a question I want to ask Yasser. All right. You do this. Thanks, board. Okay, try that one out. Remember when I go d over dx of tan x, your answer is just equals this, because it's the derivative of tan x, right? Equals that. So for this one, we would have 1 over 1 plus x squared. X just happens to be 4. Why are you wedding me?
That is what it is.
Why are you waiting?
Why are we letting me?
Because you were like, X just happens to be 4.
X happens to be 4x.
The equation was wrong.
You just said 4.
You know what? We have to roll back the tape. And I haven't downloaded it yet, so we can't. Sorry. I think I said 4x. Cool.
And
Times what?
4.
4. Maybe that's where it says it's 4, 4. Okay? Okay? You guys didn't let me keep going. You attacked me in the middle like vultures.
Why would
Okay. So we're going to get 4. 1 plus 16x squared. They'll often expand this one because, well, it's short. 3. What? You know what? Because of this, I'm going to give you this one. Sine tan negative 1x. It's actually not that bad. Is this a product rule or is this a chain rule? It's a chain because there's only what? 1x. If it was sine x tan negative 1x, then it would be product rule because sine x would have an x, tan negative 1x would have an x, 2 x's would make product rule. Because there's only one, it's chain rule. Go. So we have to do the derivative of sine first, correct? Derivative of sine is cos tan negative 1x. And then what do I have to do?
derivative inside.
Derivative of the inside, yeah. So we get 1 over 1 plus x squared. And then they'll take that 1 plus x squared, drop it underneath. So they'll go cos tan negative 1x over 1 plus x squared. Last question. Why did it just do that? I didn't do anything. Just moved while I was separating. Okay, this one is the function f of x equals
No. Never.
no, I'm gonna do that tomorrow. It's inverse functions, but not inverse trig functions. So you know what? Check that. Homework is, this is section 3.3. So tomorrow, what we will be covering are inverse functions that are not trig functions, because they can give us ask us for inverses of like a polynomial. We'll do that tomorrow. And then we're also going to do implicit differentiation. Implicit differentiation is when you have the x, y's mixed. But we're going to do when I ask you for a y double prime instead of just a y prime. What do we have to do? Okay? Now that we have our y primes down, it's easier to add the y double prime. I used to do them together, but then I feel wrong. Okay, so your problems, and then you might just want to wait because I'm going to put them in order, but there are going to be gaps like normal. AP practice. So yeah, 27, 35, 1, 4, and 6. And then we'll do 25 and 20. 25. $37. And then I want you to do an implicit with a trig, with a inverse trig. So I want you to do 44. So this is where there's an x and a y mixed, and the inverse trig has a y. Yep.